Thank you. So my name is Balazs Bucsay, and I'm going to present you the siege route, how to break out from various siege route solutions. And yeah, a little bit about me. I'm a Hungarian hacker from the neighborhood. I have some strictly technical certificates listed on the slide. I just started last week working for MRG Effitas. I'm doing research on antivirus and endpoint security products, malwares, antiviruses, and that kind of stuff. I started hacking with Ringo debuggers back in 2000. Okay. So I started with Ringo debuggers in 2000 and disassemblers when I was 13 years old. And I had one major project in 2009. Please raise your hand if you know about the GI John. Okay, I thought so. Only one. It was a distributed password cracker based on John the Ripper. And I had some presentations around the world, including US, UK, Russia, Norway, and now here in Austria. Thank you for inviting me. There is my webpage, my Twitter account. If you like my presentation, please follow me. And there is the LinkedIn webpage of my professional life. You can find everything on that page about me. So let's start with a little bit of history. siege route was introduced in version 7 Unix in 1979. Then BSD inherited this system call, and later in 2000 the FreeBSD implemented a hardened version of siege route. It is called jail. In the same year, the Virtuoso or OpenVZ implemented the containers. 5 years later, there was something called siege route on steroids. This is the Solaris container. And in 2008, the Linux containers were introduced, and those are part of the Linux kernel, the main Linux kernel today. So what is siege route? Siege route is a privileged system call, so only root can call it. And when you have a process that has a process structure in the memory, and in that structure you have different entries. One of those entries is the root vnode, and that is pointing to the root of the file system. With this system call, you can change that root vnode to another directory, so the process will think that the root of that process, so the process will think that it has a different root, so it won't be able to see anything above that root in the file system. So it prevents the process to escape that directory. Why is it privileged? It's really easy. The answer is really easy, because that way we can prevent the privilege escalation exploits with it, because it would be really easy to escalate your privileges by calling the siege route and making a crafted environment and gain root. So what is this tool used for? This is used for testing environments, dependency control, compatibility, and recovery. For example, if you have a crashed Linux box, then you can grab a live CD, put it in, boot the live CD, and later when you have the working kernel, then you can mount the crashed partition, and that way you will be able to see each root into that partition. So you will have a working kernel from the live CD and the crashed partition that you mounted with your files and your tools on it. That way it's really easy for you to fix up your crashed box and make it working again. So that's a working scenario for siege route. And there is one other scenario where you can use it. It's privilege separation. Maybe it's not a best idea to have, but you can decide on it after my presentation. Before I start the stuff that matters, I would like to ask you a question. What do you think? Is it a security feature? Please raise your hands if you think so. Okay, I guess everybody was right because this is the answer. It is not a security feature. It was used to be a security feature when they implemented it in version 7 Unix, but later they realized it is really hard to keep it secure, so they just say it is not a security feature and they don't care too much about this. If you still want to do a Chw00t environment, then you have to make sure that you are keeping these golden rules here. First of all, you have to make sure that all of the directories are owned by root, the user and group, and you have no processes running in the Chw00t environment as root user. If you are running any process in the Chw00t environment, and you will if you are creating one, then you have to make sure that all of the user IDs and group IDs have to be distinct and unique, and no files, no sensitive files can be modified by the user who is running the process in the Chw00t environment. If you are writing a tool, an application that is using the Chw00t system call, then you have to make sure that before calling the Chw00t system call, you close all the file descriptors that are open in the memory, and you use the chdir system call as well to change the current working directory. One more thing, what you have to make sure is not mounting the proc file system. You shouldn't mount it. I just read a few days ago an article about Chw00t related to Debian. They had a tutorial with best practices how to make Chw00t environments, and they recommended to mount the proc, but please don't do that because it's a really trivial way to get out. And if you don't need any kind of files or directories in your Chw00t environment, then please just use the var empty directory because that's the reason why it's there. So there is two distinct scenarios where you can met the Chw00t environments. First, when you have SSH access to the box, which is Chw00t. I mean, your user and process will be Chw00t, so you cannot escape your directory, your home directory. Or when you have an access to an FTP server where you can upload different kind of scripts, PHP and CGI, and that way you can execute any kind of script commands in the context of the Apache, which is Chw00t. Last but not least, you can have a vulnerable application which is Chw00t, and you have an exploit for that, and you can execute assembly code in the context of that vulnerable application. Or the other scenario, when you have only SCP or FTP access, and that is Chw00t into a directory. First, I will talk about the first scenario and give you examples on how to break out different ways. Most of the techniques are doing like this. First, you have to get root somehow, but not all of the techniques needed. If you have root, then you have to find a file descriptor that is pointing to a directory which is outside of your root, and that way you can find the original root and just call the Chw00t system call on that, and you are escaped. It's pretty easy, but still sometimes it's hard to do it. There is a big difference between Linux and FreeBSD, for example. I'm going to tell you, but first I'm going to show you an example here. So this is the full file system. On the top we have the original root. Under that we have all the necessary directories, the bin, the etc, home, and user, for example. And in the home we have the Chw00t directory. If we call the Chw00t system call on that directory, then the process will think that's the root and it won't be able to see anything outside of the chroot directory. Then later we can call again that system call on the chroot2, and the process won't be able to see the previous directories as it should be. So the big difference here that between, for example, Linux, but Mac OS X and Solaris working work like the same, and between FreeBSD, that Linux has only one structure for the process, and it stores all the necessary entries in that structure. The root vnode is just one entry, so if you overwrite that entry, then it will forget about the previous one. On FreeBSD, it works differently. It stores the linked list, and if you change the root, then the linked list will be added with one more item, and that will be the new root. So after you change the root here, on Linux, it will forget about the original root. On the FreeBSD, it will store a linked list, and the first item of the linked list will be the original root, and the second one is the chroot. If you call the chroot system call again, on Linux, it will remember just the chroot2 directory. On FreeBSD, it will remember all of the 3 directories. So if you somehow manage to get out this file structure, this structure, you can escape that. Then on Linux, for example, you will be able to see the full file system like this. But on FreeBSD, you can only see the last one. That's the big difference between the two. One of the chroot escape techniques that I'm not going to talk about is the kernel exploitation or kernel module. If you somehow can insert a kernel module into the kernel, which is malicious, or you can get root somehow with a kernel exploit and you can access the kernel space, then you can modify any kind of process memory, including the process structure, so you can replace just the root vnode entry in that process structure, and that way you can modify the running process and then break out of the chroot. But this is a really different topic, so I'm not going to talk about this. Let's say the zeroest technique is the misconfiguration, as always. So if you have a chrooted environment and you have some files or directories that are misconfigured, for example, the etc passvd password or shadow file, then you can modify that. You can replace your UID and you get root. Or if you have a hard-linked Chw00t binary which is loading the shared libraries from the chrooted environment, and you can replace the libpem shared library from the lib directory by just modifying the library or deleting it and moving their malicious one, then that Chw00t binary will load that shared Chw00t program will load the shared library, and that way your malicious code will run with higher privileges. This is the first technique, the classic one. It's really famous. If you Google how to escape chroot, then you will find this one. Everybody references to this technique. I sent a few mails about chroot escape, different techniques to the Linux kernel development list. They came back with this technique, that they know about this and they don't care, and try to tell them this is a different technique, but they didn't care. So that's the end of it from my side. So this is the most trivial one. This is the full file system, and we have a process that is chrooted in the red box, red folder. That is the root of that process. And the yellow one is the current working directory. And what we are going to do here is calling the chroot system call on the user3 directory. You would think that the process won't be able to see anything of the file system, but because we have the current working directory, in the home, which is outside of the root. That way it will be able to see everything on the file system. So that's the big trick here. The second technique is based on the first technique, on the classic technique, but with a little bit of trick, because we are saving a file descriptor here. So this is the full file system. Again, the red one is the root of the process, which is Chw00t in that directory. The current working directory now is the user3 directory, and we will call the Chw00t system call on that directory in a minute. But before we are doing that, we are opening the home directory and saving the file descriptor that is pointing to the home directory in the memory. And after that, we call the Chw00t system call. That way, we will have our new root. We shouldn't see anything because our current working directory is the same directory, so we are inside of it in that enclosed environment. But we have a saved file descriptor outside of our root, so that way we will be able to see everything on the file system. The third technique is the Unix domain sockets. These are really similar to internet sockets. You can create a socket, connect to it, bind on it, listen on it, and so you can connect two different processes and pass different messages between it. The best thing about this that it doesn't need any kind of networking interfaces, so it just touches the disk and that's it. And you can pass any kind of structure between the two endpoints, including file descriptors. And on Linux, you can create abstract Unix domain sockets, which means it doesn't create any kind of sockets on the disk, just in the memory, so it doesn't even touch the disk. So it won't have any trace after you did this. So this is the original file system, and we are enclosing our process in that directory, so it won't be able to see anything outside, but we want to break out. What we are doing here is running our process with what will fork another process, which will be a child process. And with that child, we call the system, the Chw00t system call on that directory. So while the parent process will have this file system structure, the child process will have this file system structure. And between these two processes, we are creating Unix domain sockets, so they can pass different structures between each other. And back to the parent process, it will open a directory. For example, here the bin is opened, and it will pass the file descriptor of the bin directory to the child process, and that directory will be outside of the child process root, right? So that way the child process will be able to see everything on the file system. The fourth technique is the mount. It's really trivial. It's working only in Linux, because Linux is not restrictive on mounting, so you can mount, for example, the root partition several times. You can create a directory in the Chw00t environment, mount the root, and just Chw00t into that. The fifth technique is the procfs. You can mount the procfs, and if you have any experience with Linuxes, probably you noticed the proc directory in the root, which is the procfs, and in that you will find lots of directories that are named as numbers. Those numbers are the process IDs on the system, and in those directories you can find lots of useful information about the processes. For example, it has the root, for example, it has the a root directory which is pointing to the root directory of that process. So in the Chw00t environment, if you create a directory, mount the procfs in it, and you find the proc1 root, then you are outside. The reason of that you have to make sure, you can be sure that this technique is working if the procfs is mounted, because the first PID is basically the init, which is always running and helps you boot the operating system that you are using. This is the sixth technique, move out of Chroot. This is the reason why I started to do research on Chroot, because I found this technique, I guess 5 years ago, but I didn't do anything with it. And I started to do this research last year only. This is really similar to the techniques that I presented just in the last 5 minutes, but somehow it's different, because we are using only file system operations to make this work. So again, this is the full file system, and we have our process enclosed in that directory. It thinks it is the root of the file system in the red box. Then we are forking that process, and the child process will Chroot into that directory, so we will have 2 different processes with 2 different roots. The child process changing the current working directory, so CDing, calling the CD GNU tool or chd or system call on the user7 directory, and what the parent do is just moving out the user7 under the child's root above the child's root. So that way the child will be able to see the full file system. And the last technique that I'm going to present you today is the ptrace. The ptrace is a system call again, but it's unprivileged. It's a really nice feature. I really enjoyed to play with this, because with this system call you can attach to other processes, and you can do different things with those processes. For example, you can get the registers of that process, you can set the registers of that process, or you can even replace the running code of that process. So that way you can attach to a process, replace the running code with your shell code, and execute anything like what you want. Root can attach to any process on the system, and users can attach to those processes that have the same UID and effective UID. Before the demo, I'm going to show you. I have a question and a gift for you here. This is a drink. I went to Estonia in September. As you can see, this is called Kali. And maybe you remember or you know this kind of drink. It's a kvass. It's a Soviet drink. Personally, I don't really recommend. I don't like it. But maybe you do. So if you can answer my question, which is, tell me a service that is usually Chroot, please raise your hand if you know an answer, then it can be yours. Please. OpenSSH. You can do Chroot with it. It's yours, I guess. I can give it to you later. No. Thanks. Okay, the demo part. Okay, it's small, I guess. Sorry, I forgot to adjust this. I guess it's better now. So I have this environment here, this directory full of files and directories, and I have the root. As you can see, this is the original root. I can access it. If I call the chroot command on it, then I will get a shell again, and if I list the root, then I can access only those files that are in that directory. If I try to leave it, then I won't be able, because that's the root of the process. And I have this tool, what I wrote. It is called Chw00t, and it supports a lots of different techniques that I already told you. which makes me able to break out from the siege root. I'm going to use the classic technique. I have to state a directory, which will be A, and just issue the command. And as you can see, I got a shell again, and if I list the directories, then I'm outside of the siege root. I exit the shell, and I'm back to the siege rooted environment. I cannot leave it again. But I'm going to show you another technique, which will be the Unix domain sockets. I have to state again the directory, which will be B, execute it. It takes a little bit longer, but we got back our shell, and as you can see, I escaped again. I have a demo for OpenBSD as well. Oops. The password is siege root. I have the this is the original root, and I have the siege rooted environment here. I'm going to use the siege root command again, and that way our process is siege rooted. It cannot see anything beyond the new root. Right now I'm root, that's why I could call the siege root system call, but I have a tool here. It's called lower UID, and if I check it now, then I'm the UID 80, so I'm an unprivileged user at the moment. And in the other terminal, I do the same, almost the same. I'm unprivileged on the other terminal as well, and I will call this sleep binary. This binary doesn't do anything, just writing out the PID and sleeps for 1 second. This is a little bit cheat to show you my demo, because what we are doing here is call my tool again. It has less support for OpenBSD, because not all of the techniques are working on OpenBSD. I'm going to use the ptrace, which is the 7. We have 2 different ptraces here. One is for 32-bit processes, and the other one is 64-bit processes. And this OpenBSD has a 64-bit, AMD 64-bit compiled. So I have to state the PID, which is this one. And I don't need to, but I want to state the port. And what I'm going to do here is just executing it. And as you can see, it stopped in the background. It doesn't write anything anymore. And I have a connected shellcode. And as you can see, I can list the full file system. So what happened here is that we had a siege-rooted environment, and outside of the siege-rooted environment, there was a process running with the same UID that we had in the siege-rooted environment. Because of that, I was able to ptrace to attach to that process outside of the siege root, replace the code of that process to a bind shellcode, and that way I managed to connect out from the siege-rooted environment into that process. To do that, I had to write my own BSD64 shellcodes, because there was nothing useful, there was nothing in the Metasploit, and I already merged and committed my module in it, so you can find it. I have one more demo for Dragonfly BSD. Just give me a second, please. So I go to the siege root directory. I call the Chw00t tool on it. And that way I won't be able to see anything outside. As usual, I have my tool in it. And I will try the fifth technique, which is move out of Chw00t. I have to state 3 different directories. And I start it. We have to wait a little bit, but it doesn't transfer anymore. And what happened here in the background, as you can see, it kernel panicked. It is a null pointer dereference, and I tried to exploit it, but I didn't manage to do that. You can find the triggering proof of concept on my GitHub, so if you want to play with it, then you can. And I reported this bug to the Dragonfly BSD developers, and they already fixed it. So back to the presentation. Here are the results. As you can see on Debian and Kali Linux, all of the techniques are working. On Ubuntu, almost all, but ptrace. Ptrace is working with root because they made the ptrace as privileged system call, so normal unprivileged user cannot call it. On Dragonfly BSD, the classic and Unix domain sockets and move out of Chw00t results in denial of service. On FreeBSD, the Unix domain sockets and move out of Chw00t only works partially, which means that because of the linked list, what I told you in the beginning of my presentation, you can break out from Chw00t environments by outside help, with outside help, but it's not really realistic. So you cannot really do anything with it, basically. But the ptrace technique is working perfectly. What was a really big surprise for me is the OpenBSD. The move out of Chw00t and the ptrace ptrace technique is working. And on Solaris and macOS X, most of the techniques are working perfectly. This is the comparison between the FreeBSD 10 Chw00t on the left side and jail on the right side. The only difference is the ptrace. The ptrace is not working inside of the jail. And in the beginning, I told you that there are 2 distinct scenarios when you can have access to a Chw00t environment, when you have shell access, and I already demoed that to you, and the other one when you have file system access only. The best thing about the move out of Chw00t technique is still working when you have only FTP or SCP access, and I'm going to show you that. And if you have only file system access, then you can still, in some cases, pop a shell or do privilege escalation, but it's really restricted, and you need to have a misconfigured system service and maybe some vulnerabilities in it. So it's not an easy task. One more topic that is related to my speech is the Linux containers. If you have a privileged Linux container that is not using any username spaces, and you can create nested containers in it, which is a really strange thing, and you shouldn't do that. Then that way you can get out to the host system from the container by using the move out of technique. And the demo again. We are back here. So I'm going to SSH into that Ubuntu box, which has some LXC containers installed. As you can see in the hosts root, there is a real root directory. And if I list the LXC containers, you can see there is a LXCO container running. To be able to do nested containers and have it privileged, you need to state these two lines here. And if you have that, you can create a privileged container with nested containers. I'm going to attach to that container. As you can see, we are in the LXCO container, and in the root of that, there is the LXCO directory. I created these. And in that privileged container, I managed to create another container, which is a nested container. As you can see, it is called LXC1. And I'm going to attach to that. In that container, in the root, you can see there is a LXC1 directory. What I'm going to do here is just go, for example, into the TMP, create a DeepSec directory, and go into that DeepSec directory. And I go back to the other terminal, which is a container on the host. So this is the host one. This is the, oh, it's maybe it's not working that well. So we have the host one. Inside of that, we have the LXCO container, and in that we have the LXC1 nested container. From the LXCO, we can access the file system of the LXC1 container. So I'm going to show you that. LXC1 rootfs. This is the rootfs of the LXC1 container. Here is the directory. And in the TMP, you can find the DeepSec. I'm going to move the DeepSec directory into the TMP, which is outside of the file system of the LXC1 container. So if I list back enough on the file system, then I can access the real root directory, so the host file system from the LXC1 container. And I can even get any file that is readable by the root. As you can see, here it is. Okay, and the last demo. Probably you know lots of virtual hosting companies where you can buy some space on their server, upload files, and run your website from their servers. You can buy a domain and point your domain to that server. And you have all the privileges and rights to modify your web page, of course. Sometimes they give you an account to your web page, which is an administration web page, where you can add different kind of FTP accounts to your home directory, so you can share your FTP accounts with your friends. Sometimes they make that mistake that you can configure your directory on that website. So I'm going to show you this one. I have a Ubuntu box which has a MySQL server on it. This should be the backend of that web page. So it has a pure FTPD database which has a users table. As you can see, there is a chroot user. It has a password which is chroot again. The UID is 1000, and the directory is home FTP chroot. So I just go to the other terminal and try to use this account. It worked. I logged in, and there is the chroot2 directory in that FTP server. In that chroot2, there is nothing, basically. And I go back to the website, let's say, and update the directory to chroot2. I open another session to the FTP, and if I list anything, then I won't see anything because we are in the chroot2. I create a DeepSec directory again. I change the current working directory to DeepSec. and I try to list everything beyond the root. And as you can see, I only see the DeepSec, right? I go back to the first session, which had a different root, and I list the Chw00t. There is a DeepSec. I rename the DeepSec, which is in the Chw00t, to, it shouldn't be like this, it should be like this. Yeah. It's successfully renamed, and if I issue the same command again, then I can access the full file system. So you can do this through FTP as well. And I can read any files that are readable for unprivileged users. So this was the demo part. I don't have any demos from now on. This is the tool. You can download it from my GitHub repository. Maybe you can find other interesting stuff there. In the future, I would like to do more testing on more operating system. For example, I don't have any accounts for AIX and HPUX, so if you have maybe and you can share it with me, then it would be really nice from you. I would like to look for other techniques that can be implemented in my tool. And if you want to help me, then please do. If you want to just fix up my shitty code, then you can do that as well. Just please come to me and we can talk about this. And lastly but not least, I would like to say thank you for my girlfriend and family for their support, Wolfie and Solar Designer for mentoring this topic, and Spender and Chw00t for reviewing my slides. These are the references. You can read it later. It can be downloaded from the DeepSec website, I guess, after the conference. This is the logo of the company where I work for now, and thank you for being here and the attention. If you have any question, maybe now is the time, or you can come to me later and we can talk about this.
There's time for 2 questions. Do you know whether this works in Docker containers?
Yeah, it's not working. They use different techniques. Yeah.
One more?
What about unprivileged LXC containers?
Sorry, what LXC?
What about unprivileged LXC containers running in user space?
It's not working. This technique is not working because these are using no user namespaces. So if you create a LXC container and root is running inside that, so that will be the root of the host container. If you are doing that in an unprivileged way, so that user namespaces will be involved with that way. So the root of the container won't be root of the file system. So it is, you cannot move things like this. And in unprivileged, I don't remember, but it wasn't working. I don't know now why. But if you have 2 unprivileged containers and you can somehow move files between them, you can mount with bind, then it can be interesting because you can see each other's thing between 2 containers.